Welcome to the video tutorial on stack implementation in Python. I'm going to show you how to implement the basics of a stack. So for those of you who are interested in Python and want to code in Python, you can use this as a guideline or a reference before you code to get the main idea, right? Okay, so let's get started. We know that stack is a LIFO data structure, right? So it means that what gets in last comes out first, right? So that's the main idea of a stack, right? This is a special data structure, and how it works and the other relevant things, all of those can be covered from the theory lecture. So yeah, please watch that before you watch this video, right? So I'll just show you how to basically code a simple stack. So so we know that there are three main operations of a stack, right? And they are push, pop, and peek. So I'll be trying to implement those basic operations, right? So what I'm going to code is something like this. I'll first create a class called stack, which represents a stack data structure, and I'll use to implement those three disparate operations. I'll be using three different methods, right? So yeah, a class for representing a stack and three different methods to represent those three disparate operations. All right, so let's get started. Okay, so there will be a class first, right? So let's write a class called stack. Yeah, and so we need a data structure, a basic data structure to store the values, right? It's a stack is another data structure which stores value in a certain way and represents the values in a certain way. But inside a stack, we need a data storage, right? So we'll be using a list, because a list is very simple to use and it has all the easy operations such as append, pop. We won't be using pop, but we can use append, right? So it has a lot of built-in data structures that we can use to implement our stack, right? So we have an empty list, let's call that stack, and we have a something called pointer. Okay, so what a pointer does is basically it points to the top of the stack, right? So when we initialize a stack class, when we initialize an object of a stack class, right, it just has an empty list called stack and a pointer of -1. So empty because there's still no value, and pointer is at -1 because there's no value, so it has nothing to point at it initially, right? Okay, so if we keep on implementing things, the pointer's value would increase and point to the top of the stack. That's the main idea, right? Okay, so we now move on to those three different methods to implement those three different operations, right? So let's first deal with push, right? Define push. So we need an element to push, right? Okay, so why push takes one argument called element, and the self is there because you need to access these values inside the method. So if you want to access global values, you should have self as an argument, right? Okay, so whenever you implement you instantiate a stack, an object of a stack, and you want to use push, then you need to pass an element to push into the stack, right? So that element would be passed as an argument over here. Okay, so what I'm going to do is this. We want to add that element to the stack. So self.stack dot append element. So what it does is something like this. It takes the element and adds to the stack and adds to this list, right? Okay. And since we have an element inserted in the stack, we would want to increase the pointer's value, right? So pointer plus equals to 1. So it increases the pointer's value by 1. We need to add self to it because you're accessing a global variable. Okay, so for if you want to visualize, let's say that first you have an empty stack, right? So if you're passing 1 into the stack, if you're pushing 1, then 1 gets pushed. If you're passing 2, then 2 gets pushed. If you're passing 5, then 5 gets pushed. So the stack keeps on increasing, right? So the pointer initially was over here, there was no pointer, and once you have appended for the first time, the pointer's value becomes 0. So it points over here. Once you have again pushed, the pointer's value increases and becomes 1, so it points over here. Again, if you push something, the pointer's value increases by 1, so it points over here, right? So we can use the pointer as an index of the stack list, right? Okay. Yeah. So that's more or less it about push, right? You just need to push the element. Okay. So then let's move on to the second function. That's solve peak, right? So again, you want to access the global variable, so you just need to have self. I'm sorry, it's self, right? And you would just want to return the top value. I mean the topmost value of the stack, right? You just want to see how it looks from the stack, right? The topmost value. So you just want to return the self.stack, sorry, self.pointer. All right. Okay. And all right, that's it for peak, right? You're just returning the topmost value of the stack from the stack, right? And you don't want to delete or you don't want to add anything when you're peaking, right? You just want to see. So peak means basically see, right? So you're just seeing and you're just being able to see the topmost value of the stack. All right. You guys already covered this in your theory, right? You already know all of this. So if you're having trouble understanding this, please watch your theory lectures first and then return to coding. All right. So the last function is pop. So again, you just want to take the last value, remove it, and return that value, right? So you need again self to access the global variables. So what you want to do is something like this, right? You want to take the last value. So let's store the last value first. Self dot stack dot self dot pointer. You want to take the last value and you want to remove the last value, so you can use list comprehension, right, to remove the last value. So I'll use the list comprehension. You already have a pop method for popping out of the last element, but since it's a built-in element and it works exactly like how we want to implement the pop method, so we won't be using the pop method of list, right? So I mean, you already have this method, right? But you can't use this because it's this is exactly what we want to code. So we won't be using this. We'll in fact code how to pop the value. So self dot stack is equals to self dot stack. We just want to discard of the last value, right? So we'll copy everything from the top or from the bottom to everything till the last value. So 0 to -1. So the last element is discarded, right? Okay, since we're popping off, the pointer's value should be decreased, and we want to return this value, right? This value, yeah, the value that was at the top of the stack initially, right? Before removing the value, before removing the top of the stack. Okay, so that is more or less it about implementing a stack, right? So let's see. All right, so what we did is basically this. We created a class called stack, and we have implemented those three fundamental operations that a stack does, and those are push, peek, and pop, and we implemented those by having different methods, right? So yeah, you'll probably have more problems, so probably more methods too, but these are just the basic what do you call those, basic operations, right? So yeah, three different methods for those three operations. So let's see how they work, right? So we're done creating the stack class, right? So let's now create an object of the stack class. So let's make something called stack1, which is basically the object of a stack class. So we have created the object of a stack class, all right? And let's say that we want to push an element. So let's say we push 2, right? And let's see whether they work. So let's see print stack1 dot peek, right? So you see we push 2, and when we peak we got 2, right? Okay, so let's print, let's say for example we want to again stack 1 dot push. Let's push another thing, right? So let's say let's push 5. Now let's see if that works. Stack 1 dot peak to see the topmost value of the stack. So see, now we have 5, since the last element inserted was 5. So if you look from the top, we'll see 5, right? Okay. Can you zoom this? Yeah. All right. So let's now let's remove one thing, right? So we have push and peak working perfectly. So let's see if we remove something. So let's say stack 1 dot pop, right? And we know that if we pop something, it returns the topmost value. So we'll be getting a value over here. So we can print that value. All right. So you see, we're getting 5 because 5 was at the top. Now if we peak again, we're supposed to, we were given 2 initially, then 5, and then we remove this 5, so we'll be left with this 2, right? So if you peak, then we're supposed to get 2. I'll print. All right. Okay, so yeah, see, first we push 2, then we push 5, so if we peak we got 5, then we remove 5, so we're getting this 5 because of popping, and this 2 because after the removal of 5, if we peak again, we'll just see this value 2. Yeah, so I guess that's more or less it about the basics of a stack. We implemented those 3 methods. We have seen how whether they work perfectly. So yeah, the rest of the problems that you'll be facing or problems that you'll be given, code them accordingly. Again, this is just a reference, or you can use this as a guideline before you code, right? So that's how you should, that is how you should proceed to solving problems, right? Yeah, thank you all for watching.